Welcome to another demonstration of What's New in NX-CAM. This video will show how you can now simulate robotic machining using NX-generated milling toolpaths. Robotic machines are useful for milling, polishing, linishing, deburring, and laser plasma and water jet cutting. In this example, we'll polish both sides of a turbine blade. We'll begin by looking at the milling tool used to create the tool path and the polishing tool that will be used in the robotic simulation. Right-click the operation and select Replay. The tool path was created by a variable streamline milling operation. Click Verify Tool Path. Select Tool from the tool list. The milling tool used to create the tool path is displayed. Select Assembly from the tool list. The polishing disc that will be used by the robotic machine is displayed. Click Play. Click OK. Display the machine tool view of the Operation Navigator. The robotic machine will use the head and polishing tool defined in this view. We'll now select a robotic machine tool from the library. Double-click Generic Machine. Click Retrieve Machine from Library. Select Robot. Click OK. Select the machine tool. Click OK. Select Use Part Mount Junction. Select the center point on the face of the mounting bracket. Click OK. Next, we'll simulate the robotic machine tool. Select the operation. Click Simulate Machine. Select Show Tool Path and Show Tool Trace. Click Play. Notice the excessive head rotation as the tool changes direction along the zigzag tool path. We'll eventually correct this J6 unwind by editing the robotic machining rules to control the head orientation. Click Continue until reset. Click OK to complete the simulation. Select the Machine Tool Navigator tab. Right-click and select Expand All to see all of the objects. Click the various objects to highlight the components of the machine tool. Right-click and select Preview Motion. Click Show Machine Axis Positions. You can use the sliders to control each joint of the robotic arm and observe the rotational limits. The blue dot for J5 indicates a singularity or excessive joint rotation of J4 and J6 caused by J5 approaching its allowable 120-degree limit. We'll correct this singularity by editing the robotic machining rules to control the joint rotation. Select the Move Spindle About Part checkbox. This allows you to observe the robotic arm movement by dragging the graphic handles. Click Close in the Preview Motion box. Next, we'll define the part component in the Setup configurator. We'll specify the blade and clamps as the part component in the kinematics chain. This will allow you to check for collisions between the robotic arm and the part and fixture. Double-click Part to edit the object. Select the blade and fixture bodies to define the part component. These three fixture bodies are the ones most likely to collide with the arm. Click OK. Next, we'll check for collisions. We'll specify two objects with which to detect collisions. J4 to J6 on the robotic arm will be the first object, and the part component you just defined will be the second object. We'll then perform a collision check using machine simulation. In the Machine Tool view of the Operation Navigator, select the operation. Click Simulate Machine. Click Simulation Settings. Select On in the Collision Detection list. Click Specify Collision Pairs. In the First Object section of the dialog box, select Component Parent from the filter list. Component Parent specifies that the selected object and all objects below it in the kinematics chain will be recognized as the first object in the collision pair. Select J4 in the name list. Notice that there are 16 objects selected. In the Second Object section of the dialog box, select Part from the name list. Type 5 in the Collision Clearance box. Click OK in the Specify Collision Pairs dialog box. Click OK in the Simulation Settings dialog box. Click Play. The J6 and part objects violate the 5 mm collision clearance you specified due to the excessive 180-degree head rotation. We'll edit the head orientation rules to prevent this collision. Click Continue until reset. As before, joint J6 does an excessive rotation or unwind. Click Continue until reset. Expand the Details section of the dialog box and click on various events to see the state of the robot at that event. Click Write to Information window to list all events, that is, things that need to be corrected in this operation. Close the information window and click OK in the Simulation Control panel. Next, we'll eliminate the collisions by editing the robotic machining rule that controls the head orientation. If necessary, add the robotic machining group to the ribbon bar. With the operation still selected, click Robot Control. The Robot Control dialog box allows you to graphically interact with the robot, set the robotic rules, apply them, and validate the results. The Robot Jog section of the dialog box determines how you wish to graphically maneuver the robot. Joint Jog displays dynamic handles at the point you specify. In this mode, you directly jog any axis from the graphic screen. Tool Control Point Jog displays dynamic handles at the tool control point. Path Position positions the tool at any point you select on the tool path. For continuous path G1, it is the same as simulation. For joint moves G0 that are part of the base operation, it does not follow the actual trace. It also does not show the move between poses. Click Path Position. Select a point on the tool path. Click Tool Control Point Jog. Rotate the head 90 degrees about the x-axis. Click Use the current Y vector of the tooltip. This captures the tool orientation you defined. At the bottom of the dialog box, select the Execute Robotic Rules on OK and Apply checkbox. This applies the rules you defined to the entire tool path each time you click OK or Apply in the Robotic Control dialog box. Click OK. Click Simulate Machine. Click Play. J3 exceeds the limits of the robotic arm. Tilting the positioner can eliminate this problem. Click Continue until reset. Click OK to complete the simulation. We'll now specify positioner rules to tilt the positioner. Click Robot Control. In the Rules section of the dialog box, select the Positioner tab. Select Constant Tool Axis from the Mode list. Select ZC from the Target Action Direction list. Click OK. Click Simulate Machine. Click Play. The positioner tilts the blade, allowing the head to remain vertical as it zigzags. Collisions and singularities have been removed. Click OK to complete the simulation. Next, we'll specify the robot configuration. The robot configuration determines the best way for the robotic arm to reach the part. Click Robot Control. Select -J3, -J5, -OH from the configuration list. This configuration causes a collision between the robotic arm and the part and is not a desirable configuration to use for this operation. Select +J3, +J5, -OH from the configuration list. This configuration does not cause a collision. Select the Configuration tab. Select Use the current configuration of the robot and click OK. Next, we'll specify non-cutting moves that will allow you to safely rotate the blade and polish the opposite side. Double-click to edit the operation. Click Non-Cutting Moves. In the Initial section of the dialog box, select Arc Normal to Part from the Engage Type list. Select the Retract tab. In the final section of the dialog box, select Same as Initial Engage from the Retract Type list. Select the Transfer Rapid tab. In the Initial and Final section of the dialog box, select Along Tool Axis from the Approach Method list. Type 200 mm in the Distance box. Select Along Tool Axis from the Departure Mode list. Type 200 mm in the Distance box. Click OK. In the Machine Control section of the dialog box, select Line from the Motion Output Type list. Note that for robotics, it is essential that you specify a linear motion output type because circular moves, spline motions, and drill cycles are not currently handled. Click Generate. Click Overwrite Toolpath. Click OK to complete the operation. Now, we'll copy and edit the existing operation to polish the opposite side of the blade. We'll also edit the robotic machining rules to specify an appropriate tool orientation and configuration. In the Program Order view, right-click the operation and select Copy. Right-click the program and select Paste Inside. Rename the operation. Double-click to edit the operation. In the Drive Method section of the dialog box, click Edit. In the Material Side section of the dialog box, click Flip Material. Click OK. Click Generate. Click OK to finish editing the operation. With the operation still selected, click Robot Control. In the Rules section of the dialog box, click the Tool Orientation tab. Click Reverse Direction. Select the Configuration tab. Select use the current configuration of the robot. Select the Positioner tab. Notice that constant tool axis is specified as the mode. Click OK. Select the program and click Simulate Machine. Click Play. Both sides of the blade are polished with no collisions or singularities occurring. Click Write to Information window to verify that there are no bad events. Close the information window and click OK. Now we'll look at controlling jog and pose settings. You can graphically jog the robotic arm to define machine poses. Once defined, poses can be used as start and end positions in the operations. We'll begin by viewing the existing poses. In the Assembly Navigator, select the Polishing Station checkbox to display the station. Displaying the station will allow you to see potential obstructions. Select the Operation Navigator. With the program still selected, click Robot Control. Select Tool Change 1 to see the pose. Tool Change 1 positions the head near the rack. Select P1 to see the pose. P1 positions the head above the part. Click Cancel. Next, we'll add a pose to an operation. Poses can be added only if an object is selected in the Operation Navigator. Select the Rough One Side 2 operation. Select Robot Control. Select a position point. Use the graphic handles to rotate the head. Drag the X arrowhead up. Select After Selected from the New Pose list. Select After Operation End in the Name list. Click Add. Type P2 and press Enter. A pose named P2 has been added following After Operation End. Notice that the Home pose is also under After Operation End. Select Home and click Remove from Branch. The Home pose is now specified as Before Operation Start, and P2 is now specified as After Operation End. Click OK. With Rough One Side 2 still selected, click Simulate Machine. Click Play. The tool ends at P2. Click OK. You may edit poses when a single operation or program is selected. When a program is selected, all operations in that program that inherit the edited pose are affected. When an operation is selected, you may only edit poses that are defined locally and used by that operation alone. A pose used by multiple operations, that is, a pose inherited from a parent object, cannot be edited when an operation is selected. In this example, we'll select the program and edit the Home pose, which is used by both operations in the program. Select the program. Click Robot Control. Select Home in the Poses list. Rotate the head about the Z-axis. Drag the X arrowhead up. Right-click Home and notice that you can update, rename, delete, and copy the pose. Select Update. Click OK. We'll now view the edited Home pose in each operation. We'll see how the Home pose has been edited for both operations while still used as start and end in the Rough One Side 1 operation and start in the rough one side 2 operation. Select the rough one side 1 operation. Click Robot Control. Select each of the 2 home poses in the list. Notice that the home pose is at the position and orientation you specified for the program and is being used as start and end for this operation. Also notice that P2 does not appear in the poses list for this operation. This is because P2 was created inside the rough one side 2 operation. Click OK. Select the rough one side 2 operation. Click Robot Control. Select Home in the poses list. Notice that the home pose is at the position and orientation you specified for the program and is being used as start for this operation. Click OK. Lastly, we'll edit a pose used by a single operation. When an operation is selected, you may only edit poses defined locally and used by that operation alone. Select the rough one side 2 operation. Click Robot Control. Select P2 in the poses list. Rotate the head about the Z-axis. Right-click P2 and select Update. Right-click P1 and notice that you cannot edit this pose. The Delete, Rename, and Update options do not appear. This is because P1 was defined in the parent Polished Blade Rough 1 program. Right-click Home and notice that you cannot edit this pose. Again, this is because Home was defined in the parent program. Click OK. Click Simulate Machine. Click Play. The operation uses the edited P2 pose as the end. Click OK. This concludes the demonstration of how you can simulate robotic machines using NX-generated milling toolpaths. Thank you.